Let's get started here. Okay, so we are going to take a look. I think my screen is shared. We'll take a look at working with strings in R. I'm very excited for this topic, and because it's a big deal. It's important. My slide deck is quite big, and so we will be looking at this today and on Friday. Okay, it's already posted. It's posted on Canvas, and so you can take a look, and the slides I don't get to, you can start looking at them, and we'll finish off the slides on Friday. So, you know, all of your other classes probably are primarily dealing with numeric data, which makes sense. Statistics has a very firm foundation in math and dealing with numeric type data, but you know, these days we've got a lot of text data, and we've got to be able to handle text. And there's kind of all sorts of areas and, you know, machine learning stuff kind of being developed to handle text type data, right? And so you have text data analysis, linguistic analysis, text mining, sentiment analysis, natural language processing. There's a lot more stuff. There's a whole bunch of like R packages devoted to natural language processing. There's a whole bunch of these things that you can kind of read about and learn. There are textbooks. This textbook, Tidy Text Mining, is available for you to read for free, and or you can spend money and buy the physical copy as well. And those are good. There's a bunch of other stuff here as well. There's some cheat sheets. I think this one is one of my links is broken here, but we'll have cheat sheets for stringer and regular expressions. I gotta fix one of those. There's a bunch of other kind of books and articles or pages that you can read. All of these you can kind of read through there. And there's a few sites where you can test out your regular expressions. And I am a big fan of this site, regexr, and this will, you type in your regular expression here. It will highlight the text that matches that pattern that you've written up here. And it will also kind of give you a little bit of an explanation of exactly what is being matched here. Okay, so this is basically, you know, capital letter followed by some words, you know, any kind of extra characters, and so this is what we have here. So regexr is a great place for testing out your regular expressions. So let's talk about just character data in R, right? So anytime we have symbols that kind of represent string data in text and words, we got these characters, right? So a string is character variable that contains one or more characters. And, you know, I just use character and string interchangeably. In Python, we call this string type, string str, and in R, it's called character type, but that's what we have in it, and it really doesn't, I use them interchangeably. So we have X. I'm going to assign the character string hello space world, hello world here. And when I ask to print out X, I get hello world in quotes, and with single square bracket 1, because the print function prints this out like this. Excuse me. And when you ask for the type of on X, R says this is type character, which is great. That's what it is. To create strings, all you have to do is use either a single quote or a double quote, and it will create string data, a character thing in R, and you can enclose single quotes within double quotes. You can enclose double quotes within single quotes, and these kind of print out. But if you want to use double quotes inside another double quote, it's going to cause an error. And in order to kind of get the double quote within another quote, you have to escape it using a backslash. So you'd use backslash double quote, and then you can include quotes inside another character thing. But If you don't, it's going to assume that this double quote closes this thing off. And then it gets confused by the existence of this new text with no kind of comma or space or operator character. And so this says, I don't know what to do here, right? So it gets confused. If there's the function, just like numeric and integers, 5 or whatever, you can create a character vector using character, and the default value inside each element of the vector is going to be an empty character. The empty character is basically an opening and closing quote with nothing in between the opening and closing quote. There's nothing in between here and here. This would be an empty character string. And so if you ask for character 5, it's going to give you a vector of 5 empty character strings. The empty character is not the same as character 0. Character 0 is a character vector of length 0, basically no elements. Whereas the empty character string actually is an element, and it would be equivalent to a character vector of length 1. So character 1 would be equivalent to having a vector with just one element being the empty character. The paste function is one of the most important functions for creating and building strings. The paste function takes inputs of one or more R objects, it converts them to character, and then it kind of concatenates or pastes them together to form one or even several strings. So here's the basic syntax. You got paste, whatever objects you want, a separator character, and by default, the default separator for paste is a space character, white space character. Collapse is set to null, and I'll explain what all of this does. Okay. There is another function called paste 0, which you will frequently see as well. And it behaves exactly the same way as this, except the default separator is the empty character. There's no character there. And so paste 0 operates in the same way as paste, except it's got a default space separator character. And otherwise, they behave the same. So let's take a look at some simple examples. Here, I'm going to give it 3 things. I've got I ate some, a string there. I give it the number pi, and I give it the string and it was delicious, and it pastes them together with a default space character separator. And now it says I ate some 3.14159, and then space, and it was delicious. Okay. Here I've got elements, bears, beets, Battlestar, Galactica, and the separator character here is a comma space. And so therefore, when it combines these elements together, it creates a single, a vector of length 1, a single character element with these comma space between them. If your elements that you give it are vectors with multiple elements in them, okay? Here I've got a character H, and here I have a vector with 3 elements, A, E, and I in quotes here. And I say the separator is the empty character. There's no separator. And I don't specify collapse because this object is length 3. What it returns is a vector of length 3. It pastes the H with the A, and it returns that. It pastes the H to the E, and it returns that. And it pastes the H to the I, and it returns that. And so we got ha, he, and hi. Here I've got 2 vectors of length 3, A, B, C in quotes. 1, 2, 3, which would be an integer vector. It's going to convert the integer vector into characters, and it's going to paste the elements element-wise. So the A gets matched with 1, B gets pasted to 2, C gets pasted to 3, and it returns a vector of length 3 here. Returns a vector of length 3. Here I specify collapse. So here I have, much like this, I've got one element that's going to get recycled. I've got a vector of length 3. So the A gets pasted with a 1, the A gets pasted with a 2, the A gets pasted with a 3, that A gets recycled. But this time, instead of returning 3 elements, okay, I'm creating a collapse. I'm providing a collapse argument. And so it is going to return a vector of length 1, where the elements are space separated by a comma space. Okay, and I want to make sure we understand the function of the collapse argument and how it distinguishes this output from this output. This output up here is a vector of length 3. This output is a vector of length 1. It has collapsed the different elements into 1. Is that okay? We've got a few functions for kind of outputting our character variables. We've got print and cat, and I think we're pretty familiar with that. We also have format. Here's just a few things I want to highlight. Excuse me, I'm sorry. I'm having all sorts of like yawning all day. I'm not boring myself, maybe. Okay, the print function here, there's actually an optional argument for quote that allows you to kind of turn off the printing of the quotation marks, right? So normally when you print out a string, you're always going to get a kind of opening quote and a closing quote down here. And you can do that, and you can turn it off by saying quote equals false. Okay. You can also call no quote. No quote called onto a string will print it out without quotes. And this looks identical, but there's a subtle distinction. If you were to store the output of no quote, it's going to be a no quote class object. And that means, anytime you call to print it in the future, it will also be printed without quotes anytime in the future as well. So here is the cat function. The cat function will concatenate multiple character vectors into kind of a single vector, and it adds any specified separator if you give it, and it outputs the results without quotations. So here X over here says hello world, and it kind of pastes it, concatenates it using here, and then it just outputs it. Okay, and so it's kind of like paste without actually returning the object. It just outputs it to the screen. The printing is different from that of no quote. So notice there's no square bracket 1 here, whereas there is a square bracket 1 here to indicate that what it's returning is a vector. Whereas cat does not actually return anything, right? Cat returns null invisibly. So if you were to try to store the output of cat, assign the output of cat somewhere, it's going to be a null. What cat does is it outputs things to the screen, maybe to a file. So if you can also specify a file, and it would take the output and output it and store it into a file. And when you use a file, you have options to either append it to the end of the file or to just wipe out the file entirely. Okay, and there's other arguments that are useful there. So we also have this function format, and what format will do is it returns a character vector, but it's going to kind of prepare these character vectors for like pretty printing. So you have a few arguments. You've got width, trim, and justify. Width will specify how wide the output needs to be in character length. Trim specifies whether there should be padding or not. Justify is, can you use spaces to kind of justify the text left, right, or center. And this is kind of like maybe a holdover from the old days where you're dealing with monospaced fonts and you want to kind of like output your data in like a text table or something like that, format could be useful in that way. Digits will specify the number of digits to use. And you can also specify n small will be the minimum number of digits to the right of the decimal point to keep. And you can specify whether you want scientific notation or not. So here I'm going to do 1 divided by 1:5. So 1 over 1, 1 over 2, 1/2, 1/3, so on and so forth. And we're going to say keep 2 digits. So I get 1.00, 0.50, 0.33, 0.25, 0.20. Okay. And it formats the output to each of these things having 2 digits. You can also specify if you want scientific notation. Scientific notation means the digit in front of the decimal point has to be something other than 0. And so you get 1.0, 5.0, 2 times 10 to the negative 1, 3.3 times 10 to the negative 1, so on and so forth. Here's just some string data, character data, and we're going to say width 10, justify left, and it basically pads each of these things so that the resulting output has 10 characters. You know, we just add spaces to these things so that this thing has a width of 10. Okay, let's get into some basic string manipulation. Let me give you your first view quiz answer for today. Today's first view quiz answer is the letter D. D as in dog. D as in dog. That will be the first view quiz answer for today. All right, so these are base R functions. These exist in base R, and I think these ones are pretty self-explanatory. The number of characters in a string, make things lowercase, make things uppercase. We have a few other things, character translation, substring, string split, and we'll take a look at those. Okay, number of characters, you give it a vector and it will tell you how many characters are in each element. So hello has 5 characters, world has 5 characters, hello has 5 characters, and universe has 8 characters. This is to lower, makes everything lowercase. This is to upper, makes everything uppercase. Pretty straightforward. Character translation is a bit of a weird function. I don't know how practically useful it is. There might be a few strange scenarios where this kind of function could be useful. So remember, y has this vector, is this vector of things that says hello world, hello universe. And what we're going to do is we're going to say, I want to replace every instance of the capital H with the letter Y. And then now we get yellow world, yellow universe. Or, you know, if you wanted to be kind of silly, you could say, I want to replace every instance of E with the number 3, every instance of L with the number 1, I with the exclamation point, and O with a 0. Okay. And so now we get H3110, W0R1D, H3110, UN exclamation point, V3RS3, right? And this is kind of like, I don't know, like there's some sub-communities of the internet that like to write things out like this as some kind of hacker type thing. And you can still kind of read what is being written here. It's just a little bit silly here. Substring says, you know, pull out starting at the second element, ending at the 9th character. Tell me what it is. So the phrase was hello world. And so the second is E, and then we go to the 9th character, which would be the R. So 2, 3, 4, 5, 6, 7, 8, 9. String split, you give it, you can split it on the spaces. So X is hello world, and we're going to split it on the space, and we get that. We get a list with 2 elements in it. Here we've got split on the letter O, and so hello world, we split on the O's, and we get hell as space W and RLD because we split on the O's. And that's that. That's basic string manipulation. I'm going to introduce this package string R. String R is part of the tidyverse and it is truly wonderful as far as handling string data and character data. And I highly recommend it. And actually, well, you're going to be required to use it. Anyway, so it says, it makes some of these R's string functions more consistent, simpler, and easier to use. And I would say this is all true. And it says, function or argument names and positions are consistent. All functions deal with NAs and zero-length characters appropriately. Output data structures from each function match the input data structures of other functions. So this is all good. Something happened when I did this, but these are kind of the functions. We got string C, which is kind of like paste, string length, which is kind of like number of characters, string sub, which is kind of like substring, string duplicate, which will duplicate strings, string trim will remove leading and trailing white space, string pad will pad a string, string wrap, and we got string trim, and then there's extra kind of resources here that I will point you to use. All right, so string C behaves a lot like paste, or paste 0 more accurately. But one key difference is that it will handle anytime you get a vector of length 0, it'll just get rid of it appropriately. So paste, if you include in the kind of sequence of things you want it to paste, null and character 0, it will insert those. So we get hello world, comma space, comma space, comma space, hello universe. Whereas string concatenate, string C, basically pastes these things together, but it recognizes that these things don't exist. It gets rid of them, and we get hello world, hello universe here. Okay. The default separator for paste is the space character, white space character, whereas for string C, the default space character is nothing. String length, which is kind of like number of characters, will work for factors. So if you call number of characters on a factor, R gives you an error because internally a factor is stored as an integer vector, and so when you try to call number of characters on an integer vector, it says I can't do that. It requires a character vector. Whereas string length says, oh, you've given me a factor, and even though a factor is an integer vector, I know what you're talking about. We'll look at the levels, and I will give you the length of the strings and the levels. So January has 7 characters, February has 8, March, April, May has 3, June, July each have 4, August 6, September 9, October, November, December. All right. So which month name has the longest name? September, 9 characters. All right. Let's talk about regular expressions. This is the true power, and this is the most exciting. Oh, a very exciting topic. This is a very exciting week. We covered deployer, and now we're doing regular expressions. You guys should be clapping in excitement here. Okay, all right. All right, thank you. All right, so we want to do pattern matching. That's basically the whole purpose of regular expressions, and we're able to express these patterns in a certain kind of a certain language, right? So regular expressions is kind of its own formal language in the sense that the symbols have a defined set of rules to specify desired patterns. And just like learning any other language, whether it's learning a foreign language or learning a computer programming language, the best way to get better at this is to use it and practice, and you'll get better. And again, going to this site regexer where you can kind of practice and just test out different strings to see what it matches, I think is a great resource. Okay, and so yeah, a regular expression is a pattern that describes a set of strings. And so here are some applications for regular expressions. You can test if a phone number has the right number of digits. You can test if a date has a specific format. You can test for an email address, or if a password meets certain criteria. You can also search for like multiple alternative spellings of words. You can search for, instances of someone's name, Will, Bill, W. Dot, or William, or something. You can see if a word is immediately preceded or followed by another word. You can do kind of searches for all kinds of things, searches for other kinds of patterns. And so as far as functions in the stringer package, we have string detect, string locate, string extract, string match, and string split. Okay. String detect returns a logical vector. It's going to return true or false, depending on whether it can find the pattern or detect this pattern in the string. Okay. String locate will return a matrix of integers. That will give you the first position, or the with the start and end of the kind of the first match of this pattern in the string. Okay, string extract will extract the text. String match will also extract the text, but as defined by capture groups. And string split will split strings into pieces. Okay. Each of these things also have an underscore all version. So you have string detect all, string locate all, string extract all, string match all, string split all. Let's just get into it and take a look at some examples. So and all of these are also in the form of the function string comma pattern. And because the string that you are searching is always the first element, this lends itself to piping quite well. So you could take some string that you've produced, and then you could pipe that string into string detect, and then you just provide the pattern. Because when you pipe something into it, it's always going to go into the first element. And the first element is always the element that we're searching for. So we're going to search for, search within this string for this particular pattern. Okay, so as far as patterns go, the simplest pattern are just literal characters. This is just kind of like when you go, if you have a document in Word and then you use the find function, you can find, a particular exact word that you're searching for, okay? And so, literal characters, we can say, I want to search for the literal character R, and capital R, and it's going to match the literal character capital R, okay? And this is kind of the most basic type of search. You're just searching for plain text. And basically all the letters and digits, letters in the English alphabet and the digits on your keyboard, those are going to be literal characters. They match themselves. So here is a string that I'm going to search within. It says, I love stats. And we are going to search for this pattern, this literal pattern, STAT, stat, okay? And string locate will return a matrix with the start and end location. So when we do this, it says, I have found a match of this pattern, STAT, and it starts at the 8th character and it goes through the 11th character, okay? And that's what we get. If you have, it's case sensitive. So if I write, I love stats with a capital S and I say search for STAT, it's going to come back and says, I can't find it, okay? I can't find little s, little t, little a, little t anywhere in this string, and that doesn't exist. Okay. What is the difference between string locate and string locate all? Well, locate all will find multiple instances. So let's say I have this vector or this longer string, love stats. I love statistics, comma. So I am a stats major, period. And I say, I want you to find the pattern STAT, STAT. So string locate finds the first instance, which will be right here, which is the 8th character through the 11th character, right there. String locate all will find this element and this one, okay? And so what it returns is a matrix, a list, and the first element in the list is the matrix with 8 through 11 for the first match, and 30 through 33 for the second match. Okay, but it returns a list. It returns a list. So the underscore all returns a list, and that might feel a little bit confusing. So I want to kind of just show you what's going on here. So I have the tidyverse already located. So here is this is what we've run, and we did string locate returns a matrix, string locate all returns a list. Okay, so what if what I'm going to do is I'm going to just create a kind of a longer vector, longer vector. All right, and I'm going to create I'm going to put in multiple things of this. Okay, and I'm going to change each of these things. All right, so we're just going to say I heart statistics and yay statistics. Okay. We'll change this. Okay. So this is now a vector of length 3. So let me show you what each of these things will do. Call this long vector. Okay. So string locate finds the first instance in I love statistics, and it goes 8 through 11. In I heart statistics, it finds the first element. So it starts at 9 and goes through 12. And yay statistics, it finds it the first element and goes 5 through 8. Okay. If I do string locate all, because there are 3 elements, it's going to return a list of length 3, and it's going to find all matches of stat. Okay. So it finds it here and here, which is going to be 8, 11, 30, and 33. I heart statistics will be 9 through 12. And over here, stat over here is going to be 31 through 34. And then lastly, yay statistics, yay stats will be 5 through 8 and 21 through 24. So string locate all returns a list, whereas string locate returns a matrix. So string locate will return a matrix of 3 rows. String locate all will return a list of 3. Each element in the list will be a matrix with however many rows there are matches. And each of these strings had 2 matches, so each of these matrices have 2 rows. But if one of these things had like 7 matches, that matrix would have 7 rows in it. Let me go ahead and give you your second view quiz answer. Second view quiz answer today is B. B as in bear. B as in bear is our second view quiz answer for today. We have a bunch of things called meta characters. These are characters that don't match themselves, and they have special meanings. And that is truly what makes the regular expressions very, very, very powerful. And so these are the meta characters. We have the dot, the caret, the $sign, asterisk, the plus, the question mark, curly braces, square braces, curved braces or parentheses, and the backslash and the vertical bar. Okay, and these are our meta characters. So the first one is the dot. The dot or the period is the wild meta character. So the meta characters, these only apply when they are inside a pattern. When you use a meta character inside a pattern, they're going to have special meaning. So if you use a dot in a pattern, it becomes a wild character, meaning it's going to match any single character except a new line character. So it also includes spaces. So here I've got a vector of words here. So I've got not, note, not with a K, and nut. And we're going to search for n.t. n.t dot being any character. So n, any character, t. And string detect said will return true or false if it finds something that matches this pattern. So this is going to return true for everything because we've got n something t, n something t, n something t, n something t, which is basically what this is. N and some character, any character t. Okay. This is NO dot. So NO some character. Where do we get a match? We're going to get a match here. NO some character, NO some character, NO some character. This is not a match. We got NU. So that's going to be true, 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 and false. Okay, what about this? I've got fives. The fives, and I apologize for the text here. So I've got 5.00, 5100, 5-00, 5 space 00. And I'm going to ask, what will string detect on the pattern? The pattern is 5.00. What will this match? What do you guys think? Match all of them, some of them, one of them, none of them. So this is going to end up matching all of them. It's going to match all of them because it's all 5 something. This is a wild card. So it's going to match 5.5100, 5-00, 5 space 00. It's going to match all of them. Okay. If you want to match the literal dot or a literal one of these meta characters, and you want a literal version to be matched, you need to escape it. You escape it with a backslash. But unfortunately in R, the backslash itself is a meta character. So you have to escape that, and you use a double backslash. Okay. So here I've got the string ABC square bracket DEF, and I want to match the opening square bracket. Now, if I say the pattern to search is going to be opening square bracket, this is going to result in an error because it's interpreting this as the meta character. What we have to tell R is, no, I want the literal opening square bracket. So we do backslash, backslash, and we do literal opening square bracket. And then it says, ah, yes, I see there is a literal opening square bracket. And so it's going to return true here. Okay, so going back here, this is what we saw, the results. When we do 5.00, we're going to get a match for all of these. If we want to match the literal dot, I have to do 5 backslash backslash dot 00. And this will match the literal 5 literal dot 00. And we will get a true for this element and false for everything else, because these do not match the literal dot there. Okay, so far so good, I hope. Square brackets can be used to define character sets, all right? And this is really great, okay? A character set will tell the regular expression search to match any any of the characters in the character set, and the character set will match only one character, okay? The order of the characters inside the character set don't matter. So we're going to say the character set defined by this will match any of the letters A, E, I, O, or U, any of these lowercase vowels, and it will match just one element of it. So let's say we call it on string detect on all of these words here, okay? So it will match here because we got P-A-N, pan. It will match this, pen, P-E-N. Pin, yes, that's a match. P0N is not a match because 0 is not one of these elements. P.N is not going to match, okay? Because this is a literal dot, and we're not trying to match the literal dot here. P-A-U-N is not going to match because even though A and U are both inside the character set matches only one character. So here is P. This is a match, but the U is not because this is not one character. We got two characters here. PWN will not match because W is not one of the letters inside the character set. Happiness will match because we do have inside happiness PIN. PIN will match this pattern here. So again, we get true, true, true for these, false for all of these, okay? False for all of these, and true for this one because of pin. All right, is that okay? Now, if you wanted to match all of the capital letters, you could do this. You could create a character set with A, B, C, D, E, F, G, all the way through Z, okay? But this is very long, very inconvenient to have to type out. So we have the dash meta character, and that will indicate a range of characters. So you could just do A through Z, or you could specify any other range. You could do A through Q, lowercase, capital A through Q. If you want all the letters, you have to do the lowercase and capital letters. You would do A through Z, lowercase, and capital A through Z, and that would be all kind of 52 ASCII letters. And then, or you could define digits, and you can do 0 through 7, 0 through 9 is probably a very common character range that you might define to find patterns in digits. So let's say we wanted to create a pattern to match 3 digits in a row, 3 digits in a row. How could we do this? Okay, well, the pattern that we are going to match is going to be this. Character class or character set 0 through 9, character set 0 through 9, character set 0 through 9. Each of these will match a digit between 0 and 9, but they only match 1 digit. So what if I want to match 3? I do 0 through 9, 0 through 9, 0 through 9. And this will match 3 adjacent digits. So it will match 1, 2, 3. Yes. No, no, no. There's only 2 digits here, so this is not a match. This is false. And there's 4 digits here, but it's just going to find, it reads left to right. So it's going to find a match at 890. So this will count as 8, 9, and 0, and that works. And so that's going to be a match there. So we get a match here, and we get a match here. All right. If you want to match 3 lowercase adjacent letters, you can do A through Z, little a through little z, and it will match that. Okay, it will match that. It will not match here because there's only 2. It will not match here because there's only 1 or 2 there. Okay, it needs to be 3 adjacent ones because it's character set, character set, character set. Each of these represents 1 character there. Any questions there? How many view quiz answers did I give you? 2. Okay, okay, good. We have the negative character set, okay? So sometimes you want to say, I want to match something that is not a particular character, all right? And so you can define a character set and you can do negation by adding a caret. You can add the caret meta character to the front of a character set, and this will be a negative character set. It's kind of like the negative sign, but for characters. And so if you have this character set, this will be match any character except A, E, I, O, or U. Okay, so I want any character except these 5 characters. All right, now we have to be careful that depending on where you put the character inside the character set, it will have different meanings. So the caret at the front means I don't want these characters. Okay. So if we do this character set caret A through Z, this will match any character that is not an uppercase letter between A and Z. Okay. So this will match true for everything except the capital A. It will match everything else. Okay, so these are all matches, these are all matches, these are all trues. The only one that doesn't match that's false will be this. If you don't put the caret as the first character, it will not mean negation. Okay, so the pattern A through Z caret becomes a character set. Okay, this will take on the literal meaning of a caret. So this will say match any capital letter A through Z or the literal caret, okay? And so we will get no matches here. We will get a match for capital A, No matches here. We will get a match for the caret here. So we're going to get false, false, true, false, false, true. What if we want to match anything except the caret? Anything except the caret. Okay. We could write this. We could write square bracket caret, and then we can escape out the caret. Okay. So this could be used to match anything except the caret. And so this will match everything. This will match all of these except the caret. True, 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 true. And a false right there. One thing to note is that when you put metacharacters inside a character set, inside this square bracket here, they kind of get automatically escaped. So actually, it was not actually necessary to do the double backslash here. Anytime you put a metacharacter inside a character set, they usually get escaped. So, for example, if I did this, P and then character set with AE.IOUN, this will match any AEIOU and the literal dot. And I don't actually need to double backslash to escape out the dot there. Okay, so this will match yes, 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 true, true, true. This is a false, but now the literal dot P dot N becomes true. This is still false because it's more than one character. And this is false because it's a W and that's not one of the values in here. Okay, so the dot inside the brace here is the literal dot here. Okay, there are exceptions. Okay, so opening and closing brackets are still behave as closing brackets. The dash still takes on its meaning, and the caret, if it's at the front, will not be literal. Okay, will still mean like kind of the negative sign. But if you put the caret somewhere else, like at the end, it will be a literal caret as well. Okay, we're going to run out of time here, so we'll leave off on this page and we'll pick up on this page on Friday. Okay, basically, there are certain character sets that are so common that we have shorthands for them. Okay, so if you want any digit, which is a very common thing, 0 through 9, you can do /D. Okay, /D. Oh. Yes, third view quiz answer. Third view quiz answer is A. A as an apple. A as an apple is your third view quiz answer. Third view quiz answer. Okay. Lecture quiz answers are always the same for lecture 1 and lecture 2. So if you attend 10 a.m. or 11 a.m., they will be the same. They are different if you for stats 21. So I'm teach stats 21. Don't get that mixed up. Okay. Those are different, but lecture 1 and lecture 2 for stats 1 and 2A will be the same. Yeah. Okay. So some of these character classes or character sets are so common that we have shorthands for them. So instead of having to write square bracket 0 through 9, we can do /D. If you want to say anything but a digit, it's /big D. Okay. So it's all. Well, I guess we'll pick up on this on Friday. Okay, you can take a look at these slides that are already posted on Canvas, and you can look at the remaining slides. It's a big slide deck. We'll try to get through as much as we can on Friday. So we'll end here for today. Have a good rest of your day, and we will see you guys on Friday.